Hi everyone, Mr. Chaffee here for today's lesson on linear equations and systems of equations. To get us started, we have some terms that we're going to go over that we're going to use throughout our lesson today. Starting off, we've got a linear equation itself, which is any equation that includes constants and variables of the first degree. Then we have properties of equality, and there are four of them: addition, subtraction, multiplication, and division. And this states that whatever we do to one side of an equation, we must do to the other, and that's just so that we can maintain equality across of our equal sign. Then we have the distributive property. Here we have a times the quantity x plus a. The distributive property just says that a gets distributed to our x and y terms individually. Then we have the associative property of addition here, which when we have three terms being added together, we can associate them in different groupings here. We're still going to get the same sum on either side here, no matter if we group a and b first or b and c first on either side here. It works out the same. Then we have our commutative property of addition, which similarly, if we add an a and b together on the left side of this equation, it's going to give us the same value as if we were to add b plus a on the other side of the equation. But now with those little refreshers out of the way, let's go over some practice example problems. Up first, we just have a couple of linear equations themselves where we can apply some of our properties of equality to solve for each of these variables. So I'm going to go ahead and work on this first one where I can see we have one equation with n in it, so I'm going to try and solve for n. I can do this by subtracting 9n from both sides to move them all to the left side of my equation. This will leave me with negative 8n minus 9 is equal to 15. Now, if I want to isolate my n, I need to add 9 to both sides, which will give me negative 8n is equal to 24. Then dividing by our negative 8 on both sides, I'm going to get n is equal to 3. So it's pretty simple. We just follow through our four properties of equality, apply our properties to both sides of the equation at the same time to isolate our variable, and in this case we get n is equal to 3. So why don't you work through number 2 and try and solve for letter n in this case by yourself. Once you think you have come up with a good solution, unpause the video when you're ready and we can go over it together. Okay, so starting off, I see we have some like terms of n on this side of the equation, so I'm going to go ahead and combine those and give me a negative 2n plus 1. Likewise, we have some constants and some like n terms over here, so I'm going to combine our n terms to give me negative 1n minus 4 on the right side of my equation here. Now, if I were to add an n to both sides, I can get just a negative n on my left-hand side plus 1 is equal to negative 4. Now let's subtract that 1. We'll get negative n is equal to negative 5, which, if we divide by negative 1 on both sides, we'll get n is equal to 5. So again, this one had a few more steps, but we're still following all of our properties of equality and isolating our variable, this time around getting n is equal to 5. Okay, let's move on to our checkpoints here. So we have 7.8 more than t is 21. What is the value of t? Here we can set up a fairly easy equation just by taking 7.8 plus t. We're setting that equal to 21, we were told. So if we want to solve for t, we can simply subtract 7.8 from both sides, which is going to get us t is equal to 13.2. Letter choice C. Similarly, letter number 2 tells us 5 less than s is 3. So if we take s, subtract 5, we're getting 3 here. And then it's asking what is the value of t in the equation of t minus s plus 6 is equal to 15. Well, first we need to solve for s. So if we add 5 to both sides here, we can see s is equal to 8. Now we can solve our second equation where we have t minus 8 plus 6 is equal to 15, which becomes t minus 2 is equal to 15, which if we add 2 to both sides, we get t is equal to 17, which is letter choice A. Alright, number 3 says the sum of 3 consecutive numbers is 129. What's the smallest of these 3 numbers? I think for this, let's just go ahead and make up some numbers. Let's say our first number that we don't know of our list is simply just x. Well, if we have consecutive numbers, our next number, we would just count up by 1, any next consecutive number. And then after that, to get the next one in our row here, we're just going to add another 1 and get x plus 2. But now we're told the sum of these three numbers. So let's add these three together. And we're saying that sum is 129. So we have this really nice, concise equation here, which we can use to find our first consecutive number, our smallest one, x, just by combining our x's to get 3 x's, combining our constants to give us 3, is equal to 129. So now by subtracting 3 on both sides, we get 3x is equal to 126. Then if we divide both sides by 3, we'll be left with x is equal to 42, which was the first of our consecutive numbers, making 42 our smallest number. Okay, number 4 says, Tim spent half of his allowance going to the movies. He washed the family car and earned $8. What is his weekly allowance if he ended with $15? So we have a lot of information here. Let's just go through these one at a time. Let's say we'll call A Tim's allowance. So we use the variable A to represent Tim's allowance. But we're saying Tim spent half of his allowance, so 1/2 of A, going to the movies. He then washed the car and he earned $8. So with $8 plus the original half that he didn't spend left going to the movies, we're saying he ended with $15 that week. So if we want to find the total sum of his allowance here, we can isolate the variable A, which is going to give us how much Tim normally earns in a given week. So if we subtract our 8 from both sides, we get 1/2 of A is equal to 7. Then we want to multiply both sides by 2. So I'll just copy that back up here. 2 times 1/2 A is equal to 2 times 7, which is going to give us A is equal to 14. So Tim's allowance is $14. It's definitely nice to have a variable choice that is some way representative of our problem, just so it helps us follow through when solving and makes it a little more sense for us once we come up with our final answer there. That's why I like to choose A, because I thought it was a little more representative of what was going on. So now let's try number 5, which says, which situation can be represented by the equation 3x plus 5 is equal to 26? So why don't you go ahead and read through our answer choices here. You can pause the video if you need to do so. And when you think you know which answer is right, unpause and let's go over the solution together. Okay, let's just read through all of these choices. We have letter A says 5 more than the triple a number is 26. Well, here we have triple a number, and then we're adding 5 to that. So we do indeed get 26 here, giving us A is a correct choice. But let's just also go through and go over each of these other answers. So the difference of 3 times a number and 5 is 26. So this would be something more like 3x minus 5 is equal to 26. Letter C says, on a test, each question X is worth 3 points. In total, the test is worth 26 points. Well, this would be more representative of just saying 3x is equal to 26. We don't have 5 in that statement anywhere. Then for D, we have Nick spends $3 on stamps, $5 on coffee, and X dollars on lunch. In total, he spends $26. Well, in this case, we would have Nick's 3 plus 5 plus X give us a total of 26 that he was spending there. So all 3 of these options are debunked, giving us A, again, is our only final correct right choice.